just when you thought we might be done with polygons, we're going to take an in-depth look at triangles today. Not exhaustive, but at least look at triangles a little bit closer as one of those polygons we talked about yesterday. So, first of all, let's classify each of these triangles by both its angles and by its sides. Okay. So triangle A there is a right triangle because it has a 90-degree angle, and it is an isosceles triangle because exactly two of its sides are congruent. So again, you might want to scribble down these definitions here, guys. It's a right triangle because it has a 90-degree angle, and it's isosceles because two of its sides are congruent. Okay, triangle B is what we would call an acute triangle, and it is equilateral as well. Okay, it's acute because all three of its angles are less than 90 degrees. All three are less than 90 degrees. That makes it acute. And it is equilateral because all three of its sides are congruent. Lateral means side. So each of its three sides. If you called it equiangular, which would actually also be true, it's because all of its three angles are congruent. And the last one, this is an obtuse triangle, and it is scalene. Okay, so it's obtuse because it has one angle that is greater than 90 degrees. It's impossible to have two angles in a triangle that are greater than 90 degrees, but it does have one that makes it obtuse, and it is scalene because its three sides are all different lengths. Scalene. Now, can we have an obtuse triangle that is isosceles? Yes, we can. Can we have a right triangle that's scalene? Yes, we can. Okay, but we can't have an equilateral triangle that is a right triangle, and we can't have an equilateral triangle that's obtuse. I will tell you that. But we can have right triangles that are scalene, and we can have obtuse triangles that are isosceles. Okay, in problems A and B, the letters X and Y represent how many degrees? Well, let's look at both of these here. Okay, X and Y represent how many degrees? Well, here's the thing. We know we've got 90 right here. Okay, all the angles in a triangle add up to 180. So that leaves 90 left over for these two angles. So, well, does that mean this is 1 and this is 89, or that this is 10 and this is 80, or is this 25 and this one's 55? I'm sorry, 65. Oops, my math is a little off. Well, because the opposite sides are equal, I know that both those angles are equal. So I'll just take 90 divided by 2, and I'll get 45 degrees. Okay, so in a triangle, if the sides opposite two angles are congruent, then the angles are congruent. If the sides opposite two angles are congruent, then the angles are congruent. Okay, and what about Y down here? Well, look, since the side opposite is 6, and the side opposite of this is 6, and the side opposite of this one is 6, that means all three of these angles are congruent. So we could do 180 divided by 3. All the angles in a triangle add up to 180 degrees, which means that each angle is 60 degrees. Next, let's find the area of these triangles. So we've done area of basically rectangles at this point in our problem sets. Today we're going to deal with area of triangles. We did a little bit in an activity earlier. Well, the area of a triangle is 1/2 its base times its height. 1/2 times base times height. The base of this triangle is 4, and the height is 3. The height is meets the base at a 90-degree angle like this. So that's height is 3. And then I'll just multiply here, and I'll get 6 square inches. Let's use some labels here, but 2 goes into 4 twice, and then 2 times 3 is 6. Let's look at this next one. Area of a triangle is 1/2 base times height. The base of this triangle is 10, and the height of this triangle is 5. 2 goes into 10 5 times, and 5 times 5 is 25, so 25 square centimeters, or centimeters squared. Okay, so this is the height because it meets the base at a 90-degree angle. 6 we did not need, 5 we did not need in the first triangle. Last one. Area of a triangle is 1/2 base times height. The base of this triangle is 6, and the height down from one vertex meeting the base at a 90-degree angle. It happens to fall outside the triangle, but it's 6 as well. Two goes in 6 3 times, and 3 times 6 is 18, so 18 square feet. All right, last thing. Mr. Torres arranges square floor tiles diagonally in a room. Near each wall, he needs to cut the tiles to fit. Sketch the shape of the triangle pieces he needs to cut, and classify the triangle by angle and by sides. Write the measures of each angle. Okay, so you can see here he's got all these square tiles laid in, but he doesn't want all these empty spaces, so he's going to have to cut some of these tiles into a shape like this. I've rotated it here a little bit, but definitely is a right triangle with 45-degree angles. Okay, it's basically just a square cut in half. So its angles are 90, 45, and 45. We would call that a right isosceles triangle. A right isosceles triangle. That's all I've got for you today on triangles. There's a lot more we can do with triangles, especially right triangles like this one, but we'll deal with that in another lesson. I'll see you soon.